Hello students, let us take a look at solved example 3 on page 141 of your textbooks. This is for chapter 8, quadrilaterals. So we have been given a diagram and the given data is that triangle ABC is isosceles with AB is equal to AC and AD is the bisector of angle PAC. I need to prove that angle DAC is equal to angle BCA and also that quadrilateral ABCD is a parallelogram. So let us go ahead and write the proof. We will write the proof starting from whatever data is given. First of all, I have been given that ABC is an isosceles triangle with AB is equal to BC. So AB is equal to BC, AC, which is given. Therefore, the opposite angles are going to be equal to each other, the opposite angles corresponding to AB and AC. The angle opposite AB is angle ACB is equal to angle ABC because ABC is the opposite angle for AC, and I will say opposite angles of isosceles triangle, and I will mark this statement as 1. Also, I have angle PAC, if you notice, is the exterior angle of triangle ABC. Therefore, PAC is going to be sum of angle ABC and ACB through exterior angle theorem. Correct? So, this is going to be angle ACB plus angle ABC, and I will say exterior angle theorem. And I will mark this as 2. So, what do we get from 1 and 2? Instead of ABC, I am going to take ACB, or let's I will write ACB because we need this angle ACB which is here. We need BCA, correct? So, instead of ABC I am writing ACB. So, I will say therefore, angle PAC is equal to angle ACB plus angle ACB, and I will say from 1 and 2. Therefore, PAC is twice of angle ACB. I will mark this as 3. Now, we have already found something for BCA. We need to equate it to angle DAC. So, how are we going to relate this to DAC? Now, if you notice, the common factor between angle ACB and angle DAC is your angle PAC. So, if you notice, AD is the bisector of angle PAC, therefore, angle PAD is equal to angle DAC. Let us write this first. AD angle PAD is equal to angle DAC. Why? Because AD bisects angle PAC. But what do we have? That PAC is made up of these two angles. Why? Through adjacent angles. But let us mark this as 4. But angle PAC is equal to angle PAD plus angle DAC. Why? Adjacent angles. Correct? And I will mark this as 5. So, from 4 and 5, instead of writing PAD, I will write DAC because we do not have any need for angle PAD, or what we need is DAC. And if you also relate, if I write DAC instead of PAD, I will get PAC is equal to twice of DAC, which is something similar to PAC is twice of some angle, and then later on we can equate the two angles, right? So, I will say that angle PAC is equal to angle DAC plus angle DAC, and I will say from 4 and 5, which makes angle PAC equal to twice of or double of angle DAC, and I'll mark this as 6. So if you notice from 3 and 6, equals that are equal to the same things are equal to each other. What do I get? That angle ACB, twice angle ACB is equal to twice angle DAC. I'll say from 3 and 6. So these are very important notes over here. Now if you divide throughout by 2, I'll say divide throughout by 2. What do you get? That angle ACB, that means you're dividing the left hand side and the right hand side with 2. When you divide something equally on the same side or on both the sides, then your equation does not change. So your ACB is going to be equal to angle DAC. But we need angle BCA. BCA is the same as ACB. If you notice, BCA is the same as ACB. So instead of ACB, I am going to write therefore angle BCA is equal to angle DAC. So this is my first part. Now I need to prove my second part, that ABCD is a parallelogram. So let's prove the second part. In order to prove that ABCD is a parallelogram, it is sufficient to prove that the alternate angle, opposite sides are parallel to each other. So let us see how we are going to prove them parallel. First of all, we have BCA is equal to DAC, which means that AD and BC are parallel to each other through the alternate angle theorem, because these two angles are alternate angles for lines AD, BC and transversal PB, correct? So I'll say, first I'll mark this as 7. Angle BCA is equal to angle DAC, and I'll say from 7. Therefore, AD is parallel to BC, and I'll say alternate angle theorem, and I'll mark this as 8. And also we've been given that CD is parallel to AB. So I'll say CD is parallel to AB, which is given, and I'll mark this as 9. Therefore from 8 and 9 I can prove that quadrilateral ABCD is a parallelogram. So I'll just write second because this is the second part we need to prove. Therefore quadrilateral ABCD is a parallelogram. And I'll say from 8 and 9. So I hope you had fun while solving this question, pretty lengthy but very simple. This was solved example 3. We'll take a look at the remaining questions in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.